10-minute series. Today we will discuss regarding consolidation. So some formulas as well as concepts. So let us start with one term, that is coefficient of compressibility. So it is denoted by AV. So let's draw one graph. You can see the x-axis is represented by stress, and this is void ratio E. Okay, so the nature of the graph is like this. So as we are increasing the stress, there will be decrease in your void ratio. So initially our void ratio is E1, final void ratio is E2. Okay, so corresponding to E1 we are having stress, that is sigma 1, and for E2 corresponding value we are having sigma 2. Okay, so basically EV is E1 minus E2 upon sigma 2 minus sigma 1. Okay, so E1 is void ratio at initial. Okay, so actually I should write bar, because here see in consolidation, always remember consolidation we are always concerned with effective stress. Okay, always remember this. So we are not concerned with direct stress or total stress, because we know what is total stress, or rather what is effective stress. Effective stress is equal to total stress minus pore water pressure. Okay, so effective stress basically is total stress minus pore water pressure. So effective stress we are denoting as sigma dash. Okay, sigma bar. So E1 I can write it is void ratio at effective stress, sigma 1 bar, and E2 is void ratio at effective stress sigma 2 bar. Okay, so we are having a ratio E1 minus E2 upon sigma 2 bar minus sigma 1 bar. Okay, now in last video I explained you one formula, that is delta V upon V0 is equal to delta H upon H0 is equal to delta E upon 1 plus E0. Okay. Next, term is coefficient of compression. Now this coefficient of compression, it is denoted by Cc. Okay, so suppose same graph, this is your void ratio. Now I am using semi-log graph so that the curve of the graph will become straight line. So now it has been converted to straight line. So here E1, so you will be having corresponding value as it is semi log, this is log scale, this is log, and here this is natural scale. Okay, so y-axis is natural scale and this is log scale. So basically it is semi log. So this ordinate will be log sigma 1 bar. Okay, same way E2, so this is your E2, so corresponding value will be log sigma 2 bar. Okay, just we have converted it into a semi log. Okay, so what is CC? So CC is basically the slope. We know slope. What is slope? Slope is basically dy by dx, or we can say y2 minus y1 upon x2 minus x1. Okay, so here what is y2, what is y1? Okay, so it is basically e1 minus e2 divided by x2 minus x1. So that is log sigma 2 bar to the base 10 minus log sigma 1 bar to the base 10. Okay, so graphically I have shown you what is the coefficient of compression Cc. Now remember one thing, that formula of Cc is equal to 0.009 WL minus 10. What is WL? So WL is percentage liquid limit. Percentage liquid limit. So it will be given to you the percentage. Now this formula is applicable for undisturbed soil, of medium sensitivity. Same way another formula is 0.007 WL minus 7. So it is for remolded soil of low sensitivity. Now another term which they are asking in MCQ is over consolidation ratio. So OCR, the formula is maximum effective stress applied in the past. Means any past history. So maximum effective stress applied in the past divided by existing effective stress. So it is basically a ratio. OCR is the ratio of maximum effective stress applied in the past to existing effective stress. So we don't know how much stress was in the past, but by some calculations, if we or by extrapolation, if we come across any graph, then we can conclude the value of OCR. Now suppose OCR is greater than 1. So what does it mean? OCR is greater than 1. It means it is a over consolidated soil. OCR is greater than 1, it means the numerator is more. Okay, so numerator is on higher side than denominator, so that's why OCR is greater than 1. So it is over consolidated soil. Suppose OCR is equal to 1, then what does it mean? It means normally consolidated soil. normally consolidated soil means both are same. Okay, maximum effective stress applied in the past is equal to existing effective stress. If numerator and denominator are same, are having same value, then OCR will be 1. So we can call it as normally consolidated soil. But suppose OCR is less than 1. So what does it mean? The numerator is less. So the maximum effective stress applied in the past was less. Okay. So, as compared to the existing effective stress. So that is termed as under consolidated soil. Okay. So sometimes you might have observed, suppose this is your ground level, and suppose some weight or some soil in the past is having deposited like this, so it will apply some pressure. Okay, so this kind of things might be there in the past, so that can be termed as the maximum effective stress applied in the past. But in present, suppose this soil has been eroded, so that this load has been removed. Okay, so these are the three conditions related to OCR, and we can conclude which type of conditions are prevailing. Okay, thank you very much.